Everybody can hear me? Clearly. Ask Rob, I don't need this mic. All right, so I guess we won't wait much longer. So welcome everybody. My name is Jason Grandelli. I'm a senior engineering manager at Urban Outfitters, Inc. down at the Navy Yard. I'm responsible for all of mobile engineering, both iOS and Android. For those of you that aren't aware, Urban Outfitters sells cat t-shirts. But we also do some engineering stuff. We have a couple of brands. Urban Outfitters, Free People, Anthropology are our major players. So for them, we have branded iOS apps, branded Android apps, and web experiences. We also have some in-store experiences as well that you may not be familiar with or may have seen. So if you've ever gone to an Apple store, you've seen them use the little sleds to kind of check you out and ring up purchases. We do some of that same software in our stores as well. So the team is maybe a little bit bigger than one might think. So today we're going to talk a little bit about what we do as far as the iOS world goes and our transition to a new programming language and how we kind of manage that transition at the same time as shipping production software on what I will now call a dead language. So first, in the beginning, there was Objective-C. We've had Objective-C for about 30 years now. Objective-C was and is still a major language for iOS development and Mac development, as well as Apple TV development and Apple Watch development. Objective-C is a superset of C, so basically that means it's built directly on top of C, so it carries, as Apple would say, all the baggage of C. As far as how it works, it's used dynamic dispatch, so it's not as statically typed as some other languages. It favors inheritance and mutability. It's kind of from the older school of software engineering and really a lot of OOP principles. There's a lot of runtime black magic, which leads to runtime errors. And it also, unfortunately, almost encourages runtime black magic because of the way that it works and the way that it's written. And because it's so old, it hasn't actually grown up much with the rest of engineering. So it has a lot of baggage, but also lacks a lot of modern features from other languages that are newer and written in the last 10 years. So all of a sudden, there was Swift. Out of nowhere, Apple just announced it one day at WWDC. No one saw it coming. And to be quite honest with you, I wasn't terribly happy. I had been an Objective-C developer for a while, and I really, really enjoyed it. And all I really wanted out of Apple was a newer, better Objective-C. Just take away the cruft, add some modernity to it, and make it a better language. And so they built a new one that I had to now learn. But according to Apple, Swift is made from the best stuff on earth, or Snapple, which one? Basically, what they decided to do was instead of writing or fixing Objective-C, they thought it had too much baggage from C, so we're better off starting from scratch in this brand new one. They could hopefully make exactly what they wanted and make everybody else happy. So in contrast to Objective-C, it's very statically typed and static dispatch. You can still do some of the runtime magic, but it is frowned upon. It's very difficult. You have to be very explicit about doing the black magic so you actually feel bad when you write it. A lot of unsafe pointers and such. It favors composition and immutability, so some newer concepts in engineering as opposed to inheritance and mutability. And then it's full of a lot of modern features that Objective-C lacked. So tuples, optional, simplified file structures, no more header and implementation files, single file for a class, access modifiers, generics, and even some functional bits thrown in for good measure. One of the other things about Swift that is inherent to the language is it's very, very safe. And Apple achieved that by implementing a very static type system. But it also, when I first got to it, felt a lot like guardrails or holding my hand. And I've been doing this for a while, so I thought, I don't want you to hold my hand, Apple. Then eventually someone told me this really great line that I kind of always use when I think about when I'm writing code, and it's, if you can't explain your code to the compiler, you should probably reconsider. So if you know more about the code than the compiler does or the computer does, you're probably doing it wrong. So Swift kind of forces you to explain your code very explicitly to the compiler, otherwise it won't actually compile. So let's talk about the situation at Urban and kind of where we were when Swift happened and when we started to think about actually implementing Swift in our code base. So we've got hundreds of thousands of lines of Objective-C split between 8 applications, consumer and retail facing, and 6 internal shared libraries. So these are private libraries, not counting the, I want to say, 7 or 8 open source libraries we also work on or contribute to or manage ourselves. So we have 9 engineers that barely, if at all, know Swift, and have never shipped it in production before. We had a long feature roadmap, nice deep backlog that had been groomed and planned, and a lot of time dedicated to that without a whole lot of time to just to start over and do it all over again. Also not a whole lot of value to our brands to say, you know what, all those new features you want, we're going to stop, we're going to learn a new language, we're going to rebuild your current feature set, and you get nothing out of it. And then even if we could start over, even if for some reason the brands had nothing they wanted to do for a couple of years, and our retail apps had nothing they wanted to do for a couple of years, we've got 4, 5, 6 years of legacy code in these applications, stuff that I've forgotten about ever existed. We have people there that don't even know about some of the parts of the code base because they're large, they're older, so we're obviously going to miss stuff. So, you know, when someone says, hey, just burn it all down and start over again, don't listen to that person. And then, to be honest, we were already a year behind on Swift. We had taken a look at Swift 1, decided it wasn't really ready, but we knew around Swift 2, we had to start catching up. We were going to fall behind in recruiting, we were going to fall behind in the industry, we were going to fall behind Apple. So we decided to go ahead and start learning Swift 2 around January 2016. So this is just over a year ago now. We completely skipped Swift 1. We tried it out. A lot of things weren't ready. A lot of things broke in dot releases and small patch releases from Apple, so we decided it wasn't ready for production, and we weren't going to go ahead and ship this to customers and possibly miss out on sales and crash the app and have poor customer experiences, just to be super early adopters and guinea pigs, to be honest. We started learning organically. At the time, our team of 9 or 10 members was split across kind of 3 geographical areas in a single building. So we weren't kind of all co-located with a single whiteboard where we could openly discuss these things. We used Slack to do a lot of our discussion, and then once in a while we'd kind of have like family meetings and huddle up and talk about really important topics. But the really great organic stuff that you get out of an engineering organization where all of a sudden when someone says headphones, you drop your headphones and you all turn around and whiteboard a problem real quick, that wasn't able to happen for the entire team. So unfortunately, we started to get a lot of knowledge asymmetry. So we'd have, you know, the team that was in pod 1 learned a particular thing about Swift and ran into a sharp corner, then fixed it and found a way around that, and may or may not have communicated it to the other 2 teams. So eventually you had these kind of 3 groups of engineers that had all learned Swift in a different way and had, you know, different levels of experience with it. And then we started to come together on code review and on sharing features and sharing code. There was a lot of just miscommunication, not being able to fully come together as a unit and actually use this language productively. So we solved this by instituting, it was a voluntold book club. So we decided to read the Apple book because A, it was free, and B, it was written by people who wrote Swift. So we figured, who better? It was really, really good. It wasn't as lame as it sounds. We had every Wednesday morning, have some coffee, pull up on the Apple TV or whiteboard, and just kind of go over a couple of chapters at a time, throw in some playgrounds, do some live coding sessions, and then also take in that time stuff from the previous week and show off how we used that in our production code or in our latest PRs. So it was really great. It actually got that knowledge asymmetry gone, and we got the entire team at the same level, able to communicate efficiently and use the language efficiently. So around that time, we kind of wrapped up learning. We know everything now. And we learned about Interop. So Apple thought a lot about Interop because obviously Objective-C and Swift have to live in the same code base, same apps. You have an application that ships, even if you write 100% Swift yourself, the entire foundation underlying UI kit is all Objective-C. So no matter what, these things have to live together and play nice for a really long time. As much tech debt and legacy code that we have in our apps, Apple's got 100 times more in their UI kit and their foundation. So they thought a lot about this, did a pretty good job, I think. And they said it just works, which, you know, we'll learn soon enough whether it works or not. So the 2 ways, there's a Swift.h file and a Bridging-Header file. These are 2 ways that Swift communicates back to Objective-C and Objective-C back to Swift. So you can actually declare Objective-C compatibility in Swift. What's nice about this is if you do this and that thing is not interoperable with Objective-C, the compiler will tell you before you compile. So we kind of got out of some of the dark places faster by, even though we didn't need to put Objective-C, just doing it. And then if you want to hide some stuff from Objective-C because it's breaking your code, you can just say, no, hide this from Objective-C, at non-Objective-C, do not show this to my Objective-C captors. And then the nice thing is that the foundation classes all bridge pretty painlessly. So going from like string to NS string and NS array to array, anything with NS is from the old Objective-C days. Next step, if you're aware. All the stuff without NS is the new Swift stuff. And then Apple so kindly went back and updated Objective-C to add support for nullability and some lightweight generics. Lightweight generics help for typed collections. So this makes your Objective-C code more predictable for Swift because Swift thrives on predictability and statically types. Objective-C just doesn't. So this was a way to make Swift actually be able to reason about your Objective-C code without having to do a bunch of dances in Swift to get around it. So just so you guys can see, this is what the modern Objective-C looks like with the interop stuff for Swift. So all the NS assume, non-null, end, and begin, that's so you can wrap stuff and say that everything between these two lines is either non-null or null. And then you'll have next to the array in the dictionary, it's very, very verbose and a little weird looking, but that's how you actually did your lightweight generics and told Swift that the things in this array are strings, and the things in this dictionary, the keys are strings, and the objects are NS objects. So interop doesn't just work, actually. Apple shipped a lot of that really great new modern stuff with Swift. None of it works in Objective-C at all, in any way, shape, or form. And honestly, why use a brand new language if you don't get to use all the fun, shiny toys? So we had to find a way to play with all the really cool stuff that made programming more fun and better and safer, while at the same time not blowing away an entire code base, 100,000 lines of code, and starting from scratch, because we already discussed why that's a bad idea. So, shims. We came up with shims. Shims is not a technical term. Shim is a thing you slam under your counter when you're putting counters in your kitchen to make sure it levels. So this is by no means technical. This is actually really dirty. It's tech debt, but that's okay. So the idea is we wanted to write really cool Swift stuff, but have legacy support. We realized early on that you don't have to do either or. You can actually do both if you throw a little dirt on it. So our priority was to learn Swift and write it in the way that the creators saw fit. We wanted to write idiomatic Swift, beautiful, pure Swift, without having to worry about the dirt that Objective-C made us rub on our bodies every day. So obviously, writing Objective-C style Swift is a waste of time. Writing Swift style Objective-C is also a waste of time. You wouldn't pick up a new language and write it exactly like a completely different language just because that's what you knew. Your goal should be to find a way to write that language the right way. And then our new Swift code obviously should be free of debt. We don't want to have to go behind in a year, 2 years, or however many years it takes to remove all the Objective-C and clean out a bunch of debt scattered throughout the application to make it play nice. So we use shims, things for your counters, things for your code, and this was to appease our Objective-C captors. They're mean captors, but they're easy to trick. So little code. This is not live code, thank God. But this is code from our production app. So this is very, very condensed in its form. Some of this code will be spread out across a couple of files, but I just want to call it out. So the top half above the ellipses, that is all Swift. So we'll go through this. We have the first one. We have an enum backed by a string. Really cool Swift thing. Doesn't work in Objective-C. Objective-C only likes enums backed by ints. Thanks, Objective-C. And then after that, we have our global function. Objective-C doesn't like global functions, only functions within scopes, so classes. And then we have this nice little shim we wrote right here, the class, and that is an Objective-C bridgeable class that has a way to access the underlying Swift code. So basically, this really dirty thing calls beautiful Swift, and then that way, at the end, the Objective-C stuff can call the dirt, and the dirt can call the Swift, and then eventually, when this is all over, we just delete everything from here down. So eventually, we have pure idiomatic Swift that has no dirt and no Objective-C. So another one, a little more complex. But we've got another enum here, because enums are really, really cool and powerful in Swift. So this one has no backing type. Objective-C would lose its mind. So it also conforms to a protocol, more no-nos for Objective-C, and it has a function in it. Enums with functions, yeah, not going to play nice in Objective-C at all. So we have an extension on Objective-C bridgeable type, once again, play nice with Objective-C. And then eventually we have Objective-C calling the extension, which eventually calls Swift. And once more, when this is all over, we delete everything from here down. Gone from the code base forever, except for in the Git history. So we got our shims down, right? Those are files that we kind of have a handful of those files across the entire app. They contain a lot of that dirt, and eventually we can just go through and gleefully delete those files. So obviously we started learning with Swift.2, so we implemented Swift.2. The retail apps were first. So our retail apps, by their very nature, are smaller, more discrete units of code. So we've got a singular app that all it does is help and associate with restocking the floor. A singular app that all it does is help with shipping and receiving. And a singular app that all it does is have a news feed for content for the resale associates. Obviously, our consumer apps, much, much larger, also much older. So a normal retail app might take a month or two to come online. A consumer app would take 9 months to a year to come online from the ground up. So it was easier to start integrating Swift in that kind of nice, quiet, small sandbox. We even started a couple of apps in 100% in Swift before there was even any Objective-C in there at all. Once we kind of got our feet wet with that and understood where all the sharp corners were, we went ahead and started rolling those into the consumer apps. They're obviously bigger and larger and scarier, but we found discrete ways to go ahead and include those. We had some ground rules. This is early on. So we obviously couldn't go and refactor everything, but we wanted to make sure we weren't fragmenting the code too much. So if we had an existing class that was written in Objective-C, and we were merely adding a little bit of functionality to it, a new button, a different view, changing an animation, we weren't going to write an extension in Swift to bolt that onto the Objective-C class. Because as a developer or someone coming behind you, you'd have to know, all right, I go to look in this file for this piece of functionality and this one for this piece. So we decided net new functionality would be Swift, so net new files, refactors, anything that was new and didn't have a lot of interdependencies with other stuff would be all Swift. And the stuff that was kind of bolted on to older stuff would live in Objective-C for now. And that was totally fine, because eventually we'd find a way to get it out. And then eventually, after that was all done, we moved on to writing net new shared libraries in Swift to make our Swift lives better, because this whole time we're kind of dealing with writing Swift and having to work with Objective-C. And after we kind of got that Swift throughout all of our applications, we wanted to make sure that the code we were using to share and make our lives better was actually better code and played nicer with the stuff we wanted to keep writing. So then the great migration happened. I don't know if you guys are aware or not, but Swift 1 was not stable. Swift 2 was not stable. Swift 3 is still not stable, and by stable I mean backwards compatible. So Swift 3 was a huge change over Swift 2. In fact, Swift 2.3, in fact, was a breaking change that Apple released to prepare developers for Swift 3. That's how bad it was. So we kind of skipped right over Swift 2.3 because there was no reason to rush there. And then because we're a retail business, we like to protect time in November and December so we don't ship a whole lot of new code in November, December, so that way our apps don't start crashing at Black Friday, because that would be silly. So due to all the ramp up to code freeze was what we call it, sometimes more like code slush, and the kind of holiday schedule, and Apple releases Swift in September, so we're not going to obviously jump on Swift 3 in September. We went ahead and started a little bit late and held off for the holiday season, so we didn't really start until November, December timeframe, and that was more in a dark fashion. So we kind of had some time set aside for that, but not shipping that to production until January. So I told you we had 9 engineers doing this. It took all 9 of them 1 month to get Swift 3 throughout all the applications that had it, migrate every line of Swift 2 code to Swift 3 code across retail apps, consumer apps, and our shared libraries. So We first tried the migration assistant that Apple ships with Xcode. That was a mistake. We quickly reverted that code. It's a nice try, and it was a valiant effort on Apple's part, but to be honest, it's just not accurate. So we ended up going through literally line by line and fixing each line of code from Swift 2 to Swift 3. The really demoralizing part about this is that meant that our applications wouldn't compile for weeks at a time. So imagine being an engineer working on an app or working on a shared library, and every time you hit run, there's another 173 errors. And then you get through all 173 of those, then you hit run again, and there's another 123. And it just keeps bouncing all over the place. This would go on for weeks, because in our code, we looked at the one project we changed 30,000 lines of code, just going to Swift 2 to 3, and that's not including the shared libraries. That's just we call the host application code. So it was brutal. We had a great happy hour after it was over, though. Went to Fedasau, got the $5 old fashions. We're good to go. No one remembers any of it. And to be honest, there's no way we would have shipped this stuff and been nearly as successful without our QA team. As diligent as the engineers were in testing that stuff and verifying that it worked, there's no way we were going to find every use case. Those people are honest to God heroes. So without them, we wouldn't have been here. I wouldn't be here. I'd be fired. So after the migration, we went forth and Swifted some more. However, we kind of had a little bit of a change of heart. We had almost a year behind us now. This is this January. Our Swift 3 code is out in the wild for all the applications. We've had all the bumps and bruises and scars on our bodies from going through a year of Swift, a year of breaking changes, and then Swift 3, and then breaking changes in dot releases. So at this point, we decided no more Objective-C, ever. Everything is in Swift. So those ground rules we had before about, oh, it's in Objective-C now, don't change it, leave it there, just go write some dirty Objective-C, no, that was gone. Now it was write an extension. Anything new, if you are touching code, if you are refactoring enough of Objective-C, if you're touching more than a couple of lines, write an extension, get it in Swift, get it out of Objective-C. Because also a lot of the bumps and bruises we had from the migration came from Interop. So we decided that was a good learning curve. We got through the don't touch the old stuff, and now we're like, no, get it out, must go. So we also actively refactor as much Objective-C as we can whenever we can. If we're light on sprint work, if we're light on feature work, we'll have people who are like, you know what? I want to refactor that view. And they go ahead and put in a ticket, and they refactor that view. Not because it needs it, just because they want to, and they want it out of Objective-C. So we actually got our product owners and our engineering team to agree to actually allocate sprint time in every sprint for technical debt. And that was whatever the engineering team decided was the most important debt at the time, whether it was refactoring Objective-C, making something even more Swiftier from its current Swifty state, or fixing some broken, janky code regardless of what it was written in. The nice thing is that our apps are relatively modular in a sense. So we can refactor a small portion of a class or a view, and then eventually that's a small part, and we refactor its cousin, and then it keep going until eventually the entire view is refactored. So we obviously started with the small stuff. We didn't start by refactoring checkout, or even the product detail page. We started by refactoring the button on the product detail page, and eventually the other button. And then eventually, the entire PDP now is all Swift. So why'd we do this, right? Like, what do we get out of this horrible journey? Our coding style has changed, something that I didn't actually expect going in. I just kind of figured we'd write some idiomatic Swift and it would be whatever. We just write Swift in a Swifty way, but the way we thought about software and engineering as a principle wouldn't have changed much, but it did, because Swift kind of leans towards certain principles. So we use a lot more composition now, a hell of a lot less inheritance. We actually just had a talk the other day internally on our mobile team meetings about the difference between inheritance and composition. And we showed some ridiculous class hierarchies in some of our projects and said, listen, this thing is 7 levels deep. We have 7 levels of inheritance on this one file. That's ridiculous. So we're actively managing that out of our code. We also favor immutability now. So we have this new kind of thing we built for our Swift version of our JSON models. We have server models, which are fully immutable. You cannot change them when they come down from the server and they're parsed from JSON into these statically typed objects. They're not mutable in any sense. If we need to change those things, we actually have a scratch model version of it. So then we'll instantiate this other model from the immutable server model. That then, if I wanted to update a SKU or change a color, I can go ahead and do that on the scratch model. And so we have a way to build a mutable version of our immutable classes, and then a way to go back to our immutable versions from our mutable classes. So it really helped a lot with our safety. We use protocols all over the place now. In Objective-C, protocols were more relegated to like the delegate sense and kind of the delegate pattern of callbacks. Protocols now, we do that to basically enable our composition. So it's really great. If you guys ever get a chance, read up on protocol-oriented programming for Swift. It's been a game changer. And at this point, we're actually flirting a little bit with functional programming. Some of our team years ago did like the closure cones and kind of studied up on some of that stuff, but really didn't take it seriously. But because Swift kind of mixes in functional programming into our daily lives, we're starting to see its value and actually starting to use it a little bit in our daily lives. We're not zealots about it, because zealotry is bad no matter what you're doing. But it's nice to kind of change it up a little bit and mix and match styles and figure out what's the right thing to use at the right time. Believe it or not, we actually like coding more now than we did before. It's really hard to see, because I always thought I really liked my job, and I still do, and I did then. But we generally have a lot of fun with this language. Like, we love just like figuring out a problem, open up a playground, doing stuff that's not related to our daily jobs, and just kind of figuring stuff out and reporting bugs. Like, I report bugs now. I never reported bugs. I report bugs. This is great. However, our compile times are really long. The one app takes 12 minutes from a clean build. So that's horrible. That's also thanks to Interop. Another reason we are managing Objective-C out of our code, because once Objective-C is gone, those compile times go way down. We're still fighting with Xcode, just different new interesting ways. Xcode will never stop fighting us regardless of the language, I think. The nice thing though is that our code is safer, much easier to read and write. Swift reads like English. Objective-C read like Sanskrit, like it was ridiculous. And the code's more performant. It's faster, safer. And a nice side benefit is we shipped thousands of lines of new Swift. We went dark for a while, and our crashes went down by a third. When's the last time you didn't ship for 3, 4, 5 months and your crashes actually went down, right? Like that's not heard of. But it's because a lot of our errors are now caught at compile time, not at the runtime. So happily ever after until Swift 4. So the nice thing is now all of our applications are anywhere between 27% and 100%. We have a couple of apps, the retail, that are 100% Swift. We have a handful of new open source and internal libraries that are 100% Swift. We've mixed in some Swift into our Objective-C libraries as well. All of our Objective-C that is still in the apps, we refactored to make it play nice with Swift, so add in nullability, add in lightweight generics, all that stuff. And slowly but surely, we are shoveling the Swift onto Objective-C's body until it is gone from our sites forever. So that is about it. Does anybody have any questions? Anything you want to ask me, comments you want to see? I can probably pull up some code if you really need me to. Rob's giving me the eye about the code.
Thanks, Jason.
Yep.
I was wondering, so I think the Swift 2 to 3 migration was a lot harder than a lot of people expected.
Same.
Like when 2 came out, I thought that, oh, this is like pretty stable and usable. They probably won't break that much anymore. And then they broke a whole ton of crap. So I'm wondering, given how hard it was, if you had known that ahead of time, would you have made a different decision now with hindsight, or are you glad that you went in on Swift 2?
I'm glad I don't have to actually live that reality. So I'm really glad we went in with Swift 2, but I already went through the Swift 3 migration. If I had known, if I had pure forethought and could travel into the future and see the pain and suffering during the migration, I don't know. That's the honest answer. But now that we're through it, I'm really glad we adopted early. We got a lot of stuff out of the way. We learned Swift before a lot of other people did. So I feel like we kind of have a leg up in the industry. We have a leg up on our team. We had some projects last year too that kind of enabled us to develop slower. So we had some major replatforming done at Urban and some kind of like already planned long dark periods. So it was a really good time to go dark with Swift. Now that we're out of that, we have much more rapid development cycles. So I don't know if we would have been able to be as successful learning Swift in today's environment at Urban as we were last year. So
cool, thanks.
Yeah. All the way in the back.
I had two questions. My first one was kind of similar to that one, where the migration from Swift 2 to 3, is a big pain. Recently, I was trying to do that, and after 2 days of effort, I just decided to stay with Swift 2 for now.
Not the worst decision you can make.
And after a presentation about weeks of suffering, I think I made the right choice based on the deadlines that we are looking.
It was 9 full-time engineers for 1 full month.
Yeah, so
that's 9 months.
To be honest, that's making me hate Swift even more. So it kind of leads me to my second question, where I'm thinking, what if we did not? So initially, our code base, I would say, is like about 15-20% Swift only, and that's also Swift 2. We had the same ground rules initially when Swift came out, where everything new and everything refactored is Swift. But anything that needs Objective-C, it's just building up, that's fine. But what happened was lately, because not many engineers are still very confident about Swift. They are more confident about Objective-C. We're still planning to continue with Objective-C for some time. I just wanted to know your thoughts on, because we don't foresee Apple dropping support for Objective-C. I don't know if that's going to happen ever. But what are your thoughts on, a code base continuing on Objective-C and just not caring about Swift?
I think it's totally valid. I don't think Apple will drop support anytime soon for Objective-C. What we might start to see is some cool new features might only be available in Swift. So then you might have to sprinkle some Swift into your Objective-C code base. The benefit for learning Swift, especially now, I think is less about being prepared for a D support and more about being in there at the very beginning, having influence in the language. We filed Jira tickets with Apple to fix parts of the language, and I then tracked those tickets and learned about why the language is the way it is by learning it now, being on the mailing list, being on Jira. So if I were to come to Swift in 3, 4, 5 years, or eventually in 10 years when Swift is the only language for the platform, if it goes that way, I may not have the same knowledge that I'm gaining now by learning it on that, kind of getting in on the ground floor, if you will. So I think the value is less about, being prepared for the future, because the future is so far out for D-supported Objective-C. It's honestly more about, A, challenging yourself, and B, like really understanding why the language is the way it is, understanding why they make the breaking changes they make. So that's it. And if all that doesn't suit you, then like maybe you want to reduce your crashes and write a more safe language that has more compile time constraints.
Thanks.
You're welcome. So is anybody? Yep.
So I am in a QA role, so I appreciate you giving a shout out to QA. I was wondering if you could elaborate more on what did they do that made them so awesome?
So what made them so awesome is that, they do a great job. They write some automated QA tests. They actually all learned Swift so they can get in there and write code with us or write QA tests and write unit tests and automated UI tests in Swift. But they knew the apps just as well as we did, just as well as the product team did, that even as an engineer, if I've, finally, after fixing the thousands of errors and my app finally compiled after 2 weeks of trying to get it to compile, and I tested out this feature and I thought, yes, I can definitely add to basket. They would find the one scenario where you can't add to basket, and I never would have found it because they have these great test scripts, they're great exploratory testers, they're extremely diligent, they've got some of the best attention to detail I've ever seen. So,
Was it testing Swift as well?
Well, so they were testing the apps in general, right? So the transition even though the code would compile, didn't mean that it was doing what you actually thought it was doing or what it was originally doing. You just got it to compile, right? You just got it not to crash. And then the engineers would also go behind and make sure that even though it did compile, does it do the same thing it did before? Does it still function the way it was spec'd? And even though we thought the answer was yes, they found lots of places where it was an absolute no. And so without them, we would have shipped functioning apps that didn't crash, but didn't actually do what the user needed it to do, which it did before. So maybe someone just couldn't sign in a particular scenario, ever, right? It's a terrible user experience, and that's a failure on our part. So without them, we would have failed big.
Thanks. You mentioned that when you were starting to learn Swift, it was just members of your team trying to figure it out on your own, right?
Yep.
So I was just wondering, why did you decide not to go and have like a formal training or invite a representative on site? And do you think it would have helped?
It probably would have helped. It absolutely would have. I think, to be honest though, it probably would have helped in the same way that instituting the book club helped. Just from my perspective at the time, the problem we faced wasn't that we didn't have someone there helping us. The problem was that we were doing it in isolated little groups without a full mind share. And so if one group stumbled, the other group wouldn't maybe see that crack in the sidewalk, and they would stumble as well. They might stumble in another direction. And then they may not find the answer, or they may not find it as fast. So by bringing the entire group together and kind of formalizing the education, it helped us kind of iron those kinks out. So I think having someone on site would have done about the same. Our group seems to have done better with the kind of do it yourself, go home and read a couple of chapters a night, come in every Wednesday and talk about it. I honestly don't know how they would have done if someone would have been there kind of talking and teaching them. They could have done great, they could have done poorly. Another universe, I guess. So any other questions, comments, concerns? Okay. I do believe ETE will have this up on their website at some point. I'll also have this in my slide share. You're welcome to go check out our repositories at Urban. Email me any questions. Honestly, I'll do code review for you. That's fine. And you can also find me on Twitter, though I'm rarely ever there. Thank you.